Well, this is another test of our new interface to Google Hangouts on the Air that we'll be using for our live video conferences on the structural modeling project. So today, what I want to do is just run some tests and some visual tests using the Selenium IDE of the new expanded structural modeling project, structural modeling software. So software is a web application which helps visualize the structure of the system as it's being developed. And the tool that I'm using here is just a web application plugin that automates the web browser, the Firefox web browser, to drive a series of steps that happen that have already been recorded in the system. So let's just go ahead and run a quick set here of test cases. We'll talk about those a little bit. So this particular one is just showing a 23 by 23 matrix go through, and we're doing one step at a time. In this particular one, it's a strict order. There are no duplicates, and so there won't be any vectors at the bottom. We're just going to just work through this and order the system. As you can see, we're going asking one question at a time. This particular approach can be optimized to reduce the amount of information you need to get, which essentially means reduce the number of green ones. But for this first start, I thought I would just take this type of basic approach and get it recorded. So here's another approach. Now here, we're using the general modeling approach because, as you can see down here at the bottom, we actually have some vectors that, meaning these are the same types. So 3 and 6 are the same, 7 and 9 are the same, 8, 11, and 12 are the same, 16 and 22 are the same. So then, of course, we have some more tests here that we're running through. Again, this is just another run of the strict order where there's only one city at each level or one item at each level of your system of interest or hierarchy. So when you order them, you start with 23 things, you will wind up with 23 things, and all you're going to do is have the proper ordering of them, depending upon the relationship that you use to structure the system. So the primary output of this then is a completely ordered system. And again, these are just some of the tests that were used to structure the these are some of the visual tests that were used to test the structuring software. Getting close to the end of this particular test case run, you can see this one we're doing a general order where we have vectors at the bottom that are equivalent, and it's essentially done. So what I'm going to do this time is I'm going to slow it down just a little, run them again, and this time you can see that some of the things that are going on. This is, again, the general order, so we should have, here we go, we have some items, see 3 and 6 are the same, they've been popped out. Now we're going through ordering the, and as we're walking up through these, you can see we're kind of doing them one at a time. So here's the next shot. This one is a strict order. There's no no vectors at the bottom of this one. And again, we're doing these one at a time. We're asking questions about the items that are next to each other and moving them up the grid if that's what's required to get them properly ordered. In this approach, so you can see that in this upper left-hand quadrant, what we're actually doing is we're starting to order and structure this part. And so once you start to order and structure those systems, you can effectively make use of binary search to reduce the amount of information you need to properly order these. We're not doing that in this case. We'll do that in the next series when we test those. But this is just a strict order. We're going through one at a time, moving them up and getting them into the position where they are, where they need to be. Each one of the green ones is an item of information, which of course costs money to get that empirical data. That's expend resources to get the empirical data. The blue ones are inferred, so that you got that information by inference. You didn't have to actually spend any resources to get that. So the real general approach here is to make sure that you optimize for minimum cost to order the system. And that minimum cost, then you want to maximize the number of maximize the number of blue ones, minimize the number of green ones. There are some strategies that you can use. One of them I just talked about was the binary search placement. There's other types of procedures and algorithms that can be used to minimize the data, depending upon the logical properties of the system's structuring relationship. Of course, in this particular one, this is just an example of a 23 cities problem, cities north of each other, ordering them, and that makes the logical properties are irreflexive, asymmetric, and transitive. You see we're working through this one. And now this one is a general order, and I don't think this one is just partial. What we do here is let's get this working, test the system, we pop up 3 and 6 at the same level. Kind of works through here, but again, we're not using any type of advanced search strategy or algorithm to actually minimize the cost of gaining this empirical data. So we're now working through this. So 3 and 6 are at the same level, 7 and 9 are at the same level, 8, 11, and 12 are at the same level. And again, you can see that as we working up, we're just working them up one at a time. So this essentially demonstrates the software's ability to do not only strict order, but also to do the general ordering and to do it and display the output to the screen. So the interesting thing is what features should be added to this. What features should, like networking, different groups. If you're working with a group of people, who should have access to this, who should not, things like that. So there's a number of questions that need to be answered and about determining the next steps of the requirements, what we're going to do. And hopefully the team will be able to address some of that in the coming months. We do have the open source software presentation. It'll be in November. Probably have a cleaned up set of the software and have a new Git repository and a new tested set of software for that community. And hopefully it'll be of interest to other people within the system science community as well. It would be I hope that we'll be able to stimulate some interest within the system science community to generate user requirements, practitioner requirements, and also help develop the requirements for the test bed, and then connect with that some interest within the open source community with people that would be interested in actually supporting the development of the software so that they can also understand the benefits of these procedures. So there's a number of strong connections between system science and, of course, the computer science and software engineering, and many of the fundamental algorithms and approaches are very, very similar. So you'll see how that works. So working through this, we've got a couple of more tests to go here, working through this again. Fairly interesting pattern. Maybe I'll speed it up just a little bit if I can. And see how that works. There we go. I think that goes a little faster. Anyway, what I'm doing is I'm using the Selenium IDE to drive the recorded test that I did for the software system. And what this does, it gives you a complete input-output and records all of the information that was put into the IDE. You can take the recorded list and actually edit it and use it as a record. There's a number of things that are very advantageous about that approach. So we're getting close to the end here. Again, we're doing the general structural order where we can have items that are all at the same level. Like here we have 3 and 6 are at the same level, 7 and 9 are at the same level, 8, 11, and 12 are at the same level. And then that, of course, shrinks the size of the matrix because we're only keeping track of the levels. So matrix itself is just ordering equivalence classes, and down here at the bottom of this little vector space, we're showing the things that are equivalent within the matrix. Just about done with this, so I think this is, I'm going to basically button this up and get it out for an example on the internet, and we'll be ready to go. This October 1st is going to be our next video conference, and might have 1 or 2 tests between now and then. We'll see how it goes. Take care and have fun.